Hello everyone. Welcome to the solution of LeetCode problem 62 named unique paths. In this problem, we are given a grid of n by m and our robot is initially positioned in the top left corner, which is here, and the robot tries to move into the bottom right corner, which is here. And the direction of the movement is the robot can only move either down or right at any point of time. That means it can go right or it can go down. So in this question, we are given two integers, which is m and n, and we have to return the number of possible unique paths that the robot can take to reach the bottom right corner. That means in how many unique ways the robot can reach from the top position to the bottom right position. Here, the test cases are generated in such a manner that the answer will be less than or equal to 2 into 10 to the power 9. That means it is suitable for the integer range. Here, the first example is the number of row is 3 and the number of column is 7 for this grid. And there are 28 paths for this robot to reach to the finishing position. And here the constant is each of the n and m value can be in between 1 to 100. I hope you understood the problem. Now let's move on to the analysis of the algorithm. And I will explain the example 1 deeply on the algorithm. Now, let's try to solve this problem by using dynamic programming. But before we solve a problem by using dynamic programming, we have to find two things. We have to determine whether this problem has some repetitive subproblem or not. And if this problem has some of the base cases. If this problem has some repetitive subproblem and also base cases, then we can say that this kind of problem can be solved by using dynamic programming. So at first, let's try to understand what is the subproblems or repetitive subproblems. Suppose currently we are presented here in these positions. So from these positions, we can go either right. Suppose by moving 1 unit right, we came here, and from these positions, we go to the downwards. Now we are presented here. So suppose initially the problem was in how many ways from these starting positions we can reach to the final positions. Now our problem is in how many ways from these positions we can reach to the final positions. So our problem reduced into subproblems. Now, suppose again we are in the starting positions. From here, we have moved downwards. Now we are presented here. And from these positions, we came into these positions again after moving to the right. Now our problem is in how many ways we can reach to the final positions from these positions. But wait, this subproblem already arrived previously. So here we can say that the subproblem in how many ways we can reach to the finishing positions from this position arrives 2 times. If I come these positions from these directions or from these directions, the subproblem will remain same. So we can say that in this problem, we have repetitive subproblems. So one condition for a problem which categorized in dynamic programming is identified, which is repetitive subproblem. Now, let's try to understand what is the base conditions. Before analyzing the base conditions, we will try to solve this problem by using bottom-up DP. Now, the base condition is, suppose currently we are presented in this node or in these final positions. Now, the base condition is there are only one possible way we can reach from these positions to these positions. So here the base condition is 1. Now, for the cell of this level and this level, there are only one possible way to reach to the final node. So for this node, there is one possible way. That means the robot can move only these directions. For this node, there are only one possible way. That means the robot can move to this direction. Similarly, for this node or this cell, it is one possible way. Here, the one possible way, and one possible way. Because for this cell, the robot can go into the one direction, this. Similarly, for this node or this cell, the direction is only one because the robot can only go to the downwards. And for this cell also, the robot can only go to the downwards. Now, for this cell, the robot can either go into this cell or into this cell, which is downwards or right. So the answer will be 1 plus 1, which is 2. These 2 comes from accumulating this 1 and this 1. Because by using the downwards positioning, we can go these positions. Then the sub problem will be in how many ways we can reach the finishing position to these positions, 1. So here, there are only one possible ways. Again, if we go to the right positions, the sub-problem will be in how many ways we can reach to the finishing positions from this cell, which is also 1. So if we do the summation operation between these two, then we will find there are only 2 possible ways we can reach to the finishing positions from this node. One is this, and another is these possible ways. So again, I hope you understood the problem now. Now, for this cell, the summation will be 2 plus 1, which is 3. That means there are 3 possible ways or 3 unique ways we can reach to final positions from this cell. Now for this cell, the unique paths will be 3 plus 1, 4. And for this cell, the unique path will be 4 plus 1, 5. For this cell, the unique path will be 5 plus 1, 6. And for this cell, the unique path will be 6 plus 1, which is 7. And for this cell, the unique path will be 2 plus 1, 3. For this cell, the unique path will be 3 plus 3, 6. For this cell, the unique path will be 6 plus 4, which is 10. For this cell, the unique path will be 10 plus 5, which is 15. And for this cell, the unique path will be 15 plus 6, which is 21. And for this cell, the unique path will be 21 plus 7, which is 28. So here, we have to return this value, 28. That means there are 28 possible ways to reach to finishing positions from these starting positions. I hope you understood the solution, and let's move on to the code. Here the code is pretty simple. At first, we are given a function named unique paths. there are two parameters, which is the dimension of the given grid. And we have declared a DP array of size 100 by 100 and initialized the value -1 to each of the cell of this 2D vector. And finally, we are calling a backtracking function. The first parameter of this backtracking function is 0, the second parameter is 0, and the third one is n, and the fourth one is m. Finally, inside this backtracking function, we have to check whether our current I and j is the finishing position or not. If our current I and j is the finishing positions, that means we have to return 1, which is the base case. Then we have to check whether our current I and j will cross the dimension of the grid or not. If our current I and j will cross the dimension of grid, then we have to return 0. Now, we have to check if we already completed the subproblem. That means if dp of ij if not equal to -1, that means we have to return dp of ij. Otherwise, we have to simply call the backtracking function from the right cell and from the downward cell and perform the summation of the return value and put it into the dp of ij. And finally, we have to return it. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n into m because we have to recursively call the backtracking function in each of the cell of this grid. So as there are n into m cell into the grid, so the time complexity is big O of n into m. And the space complexity also is big O of n into m because we are taking a dynamic programming array or 2D dynamic programming vector to store the result. So here we can say that the space complexity is also big O of n into m. Thank you everyone for watching this video. We will get back soon with another LeetCode solutions.